MaskBid, price discovery for real-world assets, private, verified, and bot-free. 3 critical problems block RWA adoption today. First, public bids. Any bot can watch the mempool and snipe the winning bid at the last second. Second, no identity layer. Unlimited fake wallets flood auctions with Sybil attacks. Third, key theft. One stolen private key and a high-value asset is gone forever. No existing platform solves all 3 at once. MaskBid introduces human-locked assets, RWA ownership bound to a verified human identity, not just a private key. Private bids via Chainlink confidential HTTP. Nobody, not even the database admin, sees any amount until the auction ends. World ID for proof of personhood, and a transfer guard that blocks any unverified wallet from receiving your asset. We built 4 CRE workflows. The auction solver is our core privacy engine. It decrypts sealed bids inside Chainlink's Vault DON enclave and writes the winner on-chain. The 2 log triggers keep our off-chain database in sync with on-chain events in real time. Here's the full product flow. Every actor, seller, verifier, bidder must pass world ID KYC through a CRE workflow before interacting. Let's see it live. We're on Tenderly Virtual TestNet, a Sepolia fork that lets us control block time and balances. 3 wallets are preloaded. A seller, 2 bidders, 1 doubling as the verifier. Quick faucet top-up, and we're live on the app. First, KYC. The seller connects their wallet and completes World ID verification. Instead of a centralized server, the proof is forwarded to our Chainlink CRE KYC workflow. Multiple CRE nodes independently call worldcoin.org and must reach consensus before anything is written on-chain. The KYC status is now stored in the smart contract, not just a database record. Here it is on Tenderly, the KYC status set event, confirmed on-chain. Now the seller registers 2 real-world assets, a Rolex Submariner and a signed canvas by Elena Vasquez. The moment each transaction lands on-chain, our CRE asset log trigger workflow fires automatically, decodes the event, and syncs the asset state to our off-chain database. Watch the terminal. You can see CRE reading the asset registered event in real time. Tenderly confirms both transactions, showing full event logs on the contract. A separate verifier role, also KYC'd, reviews the asset documentation and approves it. Once verified, they mint the ERC1155 token representing the Rolex on-chain. Again, CRE log trigger picks up both events instantly. Asset verified, then tokens minted. And the asset state is updated across the whole system. The RWA is now a live tokenized asset on Tenderly Sepolia. The seller selects the Rolex token and creates a sealed bid auction, setting a start price, reserve, and end time. The ERC1155 token is escrowed directly by the smart contract. The seller no longer holds it. Greater than CRE auction log trigger fires on the auction created event, syncing the new auction to Supabase so it appears in the UI immediately. Before we place real bids, let me show you something powerful about our development setup. Tenderly, we can simulate any contract function directly. I'll call set auction, aim start time to now so the auction is live and we can bid right away. Bidder 1 is already verified. They open the auction and see the Rolex listing. Notice there are no prices shown. No one can see what others are bidding. They type in their amount and hit submit. At that moment, the app locks the number. It's hidden before it even leaves the device. What goes to the blockchain is just a fingerprint of the bid. What goes to our database is scrambled data that no one can read. Not the seller, not us, no one. Their USDC deposit is held by the smart contract, locked in, trustless, no middleman. Now I'll place a bid as the second bidder. Let's speed through this step. The auction now shows 2 bids, still no amounts. Auction time is up. We run the CRE auction solver. In local simulation mode, which simulates the confidential HTTP capability. Watch the terminal. The workflow fetches all the encrypted bids from Supabase, passes them to the solver, and the solver decrypts them to find the highest bid. Notice the solver auth token in the code is just a placeholder. Double curly brace solver auth token. The real token is injected by VaultDon at runtime. It never lives in our code base, never in our database. The winner is selected, an ABI encoded report is submitted on-chain through the forwarder, and the contract flips to pending claim. The winner is revealed for the first time by the blockchain itself. Settlement is a 2-step claim. But first, remember when they placed their bid, they locked up a USDC deposit as collateral. To actually claim the asset, they now pay the full winning bid amount. That USDC goes to the seller, and in return, the Rolex token transfers directly from escrow to their wallet. The losing bidder calls claim refund. Their USDC is returned in full. Trustless, no intermediary, on-chain, verifiable, final. That's MaskBid, private bids, human verified identities, and trustless settlement, all powered by Chainlink CRE.